Let's see this particular problem, which is given in chapter 2, structure of atom. The question is saying that all in the radio broadcast on a frequency 1368 kilohertz. So they have given you the frequency and you are required to calculate the wavelength of the electromagnetic radiation. Radio broadcast is an electromagnetic radiation emitted by the transmitter. The theory of electromagnetic radiation was given by James Clerk Maxwell in 1870s. It says that whenever there's a movement of charged particle, and if the charged particle accelerates, then it will emit electromagnetic waves. And the speed of electromagnetic wave is same in vacuum. It's 3 into 10 to the power 8 meter per second. That we generally say the speed of light in vacuum. Light is also light visible, the light that through which we see everything, which comes from the sun, is also a part of electromagnetic radiation. It's a kind of electromagnetic radiation which has some special wavelength. The wavelength of the visible range has a wavelength of 400 to 750 nanometer. It's called visible range, and its corresponding frequency is around 10 to the power, which is equivalent to 10 to the power minus 7 meter. It's very small, and a frequency of 10 to the power 15 hertz. That's this many hertz. Means hertz is a frequency of hertz is a unit of frequency. Uh, 1 hertz means one wave is passing in 1 second, right? So frequency is number of waves that are passing through a particular point in 1 second. That's called frequency. There's a relationship between the velocity of the wave, which is constant, at its frequency, and the wavelength. What is a wavelength? This is how I'm depicting a wavelength from trough to trough or from crest to crest. The distance between the two adjacent trough or distance between two adjacent crests. Or if you take from here, then here to here will be one complete wave, and its length will be the wavelength. So this is constant. Constant, that means the frequency and the wavelength of a particular wave is inversely proportional. If the wavelength increases, its frequency will decrease, and if there is an increase in frequency, then the uh, wavelength will be less. Now let's put the things that isn't given in in the equation. So this is the equation which depicts the relationship between the velocity of electromagnetic wave, its frequency and wavelength. C is equal to nu into lambda. So if you want to calculate the wavelength that is denoted by lambda, it will be c divided by frequency. C, the velocity of light in vacuum. One more thing, electromagnetic radiations, they do not need they unlike sound waves, they do not need a medium to propagate. So if it's coming from sun, if it is coming from sun or if it is coming from radio, it doesn't need a medium to be there. It can be transmitted easily. It doesn't need a medium to travel. This electromagnetic waves doesn't need a medium to propagate, get transmitted. So even if there's a transmitter in the moon and it transmits electromagnetic waves, it can be received on Earth, even though there is a space between moon and Earth, which is a kind of vacuum. It's nothing there, not even air. Still it can reach Earth from moon to Earth. So now velocity of the light or electromagnetic radiation in vacuum is constant, 3 into 10 to the power 8 meter per second. This many meters in 1 second. This is the speed. And it is constant if it is in a vacuum. Divided by frequency is 1368 kilohertz. Kilo means 10 to the power 3, right? So if you simplify 10 to the power 8 and 10 to the power 3, it will become 10 to the power 5. 3 divided by this. So let's take 3 zeros from here. 3000 by 136. So what remains is 10 to the power 2. 3000 by 1300 is this. I think it's around half of it. So 3 by 2 will be 3 by 1.5, half. The half of 3 will be how much? 1005. 2, that is 2 into 10 to the power 2. It's around 200 meter. It's a very long wave. In fact, radio waves, they have a wavelength from 10 to the power 0 to 10 to the power 8, which is like 1 meter to 10 to the power 8 meters. It will be, the length will be 1 meter, or it can be up to 10 lakh meter. 10 to the power 8 means how much? 10 to the power 8, 5 is 1 lakh, 1000 lakh meter. Like 1000 lakh 5, yes, 1000 lakh meter. If it is, even if it is of that much length, it may be up to that much of length, the wavelength, one wavelength. Radio waves consist of this FM, that will often listen radio, AM, and long radio waves. FM means frequency modulated, this amplitude modulated. So this wavelength corresponds to, if a wavelength is around 10 to the power 1 to 10 to the power 8, it corresponds to radio waves, and its frequency is around 10 to the power 6 hertz. If you consider that to this, the wavelength, if the wavelength decreases, for a visible range of wavelength is around 10 to the power minus 7 meter, right? 10 to the power minus 7 meter, and its frequency is 10 to the power 15 hertz. It was 10 to the power 6 hertz, now it's 10 to the power 15 hertz. This is around 10 to the power 6 hertz. I hope it's clear.